Namaskar, I am Anand and you are watching Join for Education. In this class, I am going to solve the questions of exercise 6.3. Name of the chapter is Maxima and Minima of functions of one variable. All questions are from NCERT textbook and from the section of application of derivative. Let's start the class. This is the first question of question number 3. In this question, ask us find the local maxima and local minima, if any, of the following functions. Find also the local maximum and the local minimum values as the case may be. Let's see the solution of question number 3 to 1. First derivative of the given function is 2x. After there is no problem to understand up to this step. The value of f dash x equal to 0 at x equal to 0. Sign of fx close to 0 to the right is positive. Sign of f dash x close to 0 to the left is negative. Sign of f dash x changes from positive to negative when we move from right to left. So the local minimum value of fx at x equal to 0 is 0. So this is the answer of the question number 3 to 1. Let's see the question number 3 to 2. Let's see the solution. First derivative of gx is 3x square minus 3 equal to 3 x square minus 1 equal to 3 x plus 1 into x minus 1. Or first derivative of gx or g dash x equal to 0 at x equal to minus 1 and 1. Sign of g dash x close to minus 1 to the right is negative. Sign of g dash x close to minus 1 to the left is positive. Local maximum value of gx at x equal to minus 1 is 2. After there is no problem to understand the solution of question number 3 to 2. For more details, attend online live class on Google Meet. Again, sign of g dash x close to 1 to the right is positive. Sign of g dash x close to 1 to the left is negative. Sign of g dash x changes from positive to negative when move from right to left. So the local minimum value of gx at x equal to 1 is minus 2. So this is the solution of question number 3 to 2. Let's see the question number 3 to 3. Hx equal to sin x plus cos x, x greater than or equal to 0 and less than or equal to pi by 2. Let's see the solution of this question. First derivative of hx, which is h dash x equal to cos x minus sin x. Of that there is no problem to understand up to this step. H dash x equal to 0 at x equal to pi by 4. Sin of h dash x close to pi by 4 to the right is negative. Sin of h dash x close to pi by 4 to the left is positive. Sin of h dash x changes from negative to positive when moved from right to left. So hx has maximum value at x equal to pi by 4 is root 2. Of that there is no problem to understand the solution of question number 3 to 3. Let's see the question number 4. Fx equal to sin x minus cos x, x greater than 0 but less than 2 pi. Let's see the solution. First derivative of fx is cos x plus sin x. F dash x equal to 0 at x equal to 3 by 4 or 7 pi by 4. Sin of f dash x close to 3 by 4 to the right is negative. Sin of f dash x close to 3 by 4 to the left is positive. Sin of f dash x changes from negative to positive when we move right to left. Therefore, local maximum value of fx at x equal to 3 pi by 4 is root 2. Of that there is no problem to understand up to this step. Sin of f dash x or first derivative of the function close to 7 pi by 4 to the right is positive. Sin of f dash x close to 7 pi by 4 to the left is negative. Sin of f dash x changes from positive to negative when we move right to left. So local minimum value of fx at x equal to 7 by pi by 4 is minus root 2. After there is no problem to understand the solution of question number 3 to 4. Let's see the question number 3 to 5. Fx equal to x cube minus 6x square plus 9x plus 15. First derivative of the function is 3x square minus 12x plus 9. After there is no problem to understand up to this step. First derivative of the function or f dash x equal to 0 at x equal to 1 and 3. After there is no problem to understand up to this step. Sign of f dash x close to 1 to the right is negative. Sign of f dash x close to 1 to the left is positive. Sign changes from negative to positive. Therefore, local maximum value of fx at x equal to 1 is 19. Sign of first derivative of the function or f dash x close to 3 to the right is positive. Sign of f dash x close to 3 to the left is negative. Sign changes from positive to negative. Therefore, local minimum value of fx at x equal to 3 is 15. After that there is no problem to understand the solution of question number 3 to 5. Let's see the question number 3 to 6. First derivative of gx, which is g dash x equal to 1 by 2 minus 2 by x square. After there is no problem to understand up to this step. If you have attend online live class on Google Meet. First derivative of gx or g dash x equal to 0 at x equal to plus minus 2. Here say that x greater than 0, so x equal to 2 acceptable and x equal to minus 2 is not acceptable. Sign of g dash x close to 2 to the right is positive. Sign of g dash x close to 2 to the left is negative. Sign changes from positive to negative. Therefore, local minimum value of fx gx at x equal to 2 is 2. After there is no problem to understand up to this step. We will not consider about x equal to minus 2 because x is greater than 0. Let's see the question number 3 to 7. First derivative of gx is minus 2x by x square plus 2 to the power 2. First derivative of gx or g dash x equal to 0 at x equal to 0. Sign of g dash x close to 0 to the right is negative. Sign of g dash x close to 0 to the left is positive. Sign of g dash x changes from negative to positive. Therefore, local maximum value of gx at x equal to 0 is 1 by 2. Let's see the last question of question number 3, which is question number 3 to 8. First derivative of fx is 2x minus 3x square by 2 x square minus x cube over root. After the cancelled out of the common factor, we get 2 minus 3x by 2, 1 minus x over root. Therefore, first derivative of fx over f dash x equal to 0 at x equal to 2 by 3. Sine of f dash x or first derivative of fx close to 2 by 3 to the right is negative. Sine of f dash x close to 2 by 3 to the left is positive. Sign changes from negative to positive. Therefore, local maximum value of fx at x equal to 2 by 3 is 2 into root 3 by 9. So, half that there is no problem to understand the solution of question 3, 1, 3. This solution will be useful schooling students of class 12 having a subject mathematics, as well as the audience who are interested in mathematics. Together with this class will be useful to the JEE main and advanced aspirants to clear their basic concepts as regard this. In this class, I have solved question number 3 to 1 to 3 to 8. In the next class, I will solve some more questions of this exercise. Till then, thanks to all of you. Thank you very much.